Okay, method of undetermined coefficients. This is what you use when you have the form ay double prime plus by prime plus cy equals some function of x. So first of all, when you're solving a non-homogeneous equation like this, you're going to take the solution of the homogeneous equation and add a particular solution. And I'll show you what that is. So the first thing you do, solve the homogeneous equation, you just drop the f at x, replace it with 0, and solve it just like you would any other homogeneous equation. Next, you're going to find a particular solution. This is just a generalized version of f at x, and we call that y sub p. So the way we do this, a couple examples here. If you have f at x is 5e to the 3x, your y sub p is a e to the 3x. If you have 12x cubed plus 4x, y sub p, ax cubed plus bx squared plus cx plus d. You just take the general form of it with undetermined coefficients. The tricky one, if you have any sine or cosine, here we have 2 sine of 3x, your general form will be a sine of 3x plus b cos of 3x. You'll have, whether it's sine or cos, you'll have both sine and cos in your yp for those ones. And if you have multiple in one, here we have 7e to the x plus x, you just include both of them. So ae to the x plus bx plus c. There's your e term, there's the x term. A little note about the finding yp. Your yp cannot contain the solution to the homogeneous equation. If it does, you just got to multiply the term by x. So here's an example. Say our solution to the homogeneous equation is c1 e to the x plus c2 x e to the x, and your yp, you want to put it as ae to the x. But you notice here, e to the x, they're the same thing, so you can't use it. So we're just going to multiply by x, ax e to the x. But then again, that's also in the homogeneous solution. So in this case, we would actually have to do ax squared e to the x. Now if you don't catch this, not a big deal. You will notice it because when you do the later steps, everything will zero out and you simply won't be able to get an answer. So if that happens to you, check for this. You probably missed something. So next thing we're going to do, we have our general yp. We're going to take derivatives of it and sub it into the equation. Get all three derivatives, two derivatives. So yp sub with y, yp prime sub with y prime, yp double prime sub with y double prime. After you've done that, you're going to factor out all your terms involving x, so you get undetermined coefficients. So it'll look just like this. You'll have a's and b's will be the a's and b's and c's, etc. from your yp, and there'll be coefficients of it. See, here we have x squared, x, and then a constant term. If you have like sines and coses, you'll just factor out the sines and cosines. Or e to the x, you'll factor out e to the x. So now this will be in the same form as f at x, so your coefficients for each term will be equal to the ones on the right hand side, and you've solved yp. So then we've already solved the solution to the homogeneous. You simply add it to yp, and that's your final solution. And I know that sounds a little bit complicated, so let's do an example. Our example here is y double prime plus 3y prime plus 2y equals e to the negative 2x. First we're going to solve the homogeneous equation. Do our R transformation here. R squared plus 3r plus 2 equals 0. So our R equals negative 2 and negative 1. So this homogeneous solution looks like this. Y equals c e to the negative 2x plus c2 e to the negative x. So next we're going to find our particular solution. Now f at x equals negative 2x, e to the negative 2x. So ordinarily we would pick a e to the negative 2x, but this is also in our homogeneous, so we're going to add an x. Yp is ax e to the negative 2x. Next we're going to take our derivatives here. I won't go through those. Basically you just take the derivative, it's very simple. So you can do that. So next we're going to sub it into the original equation. So we have yp double prime plus 3yp prime plus 2yp equals e to the negative 2x. We sub in our derivatives from up here, and you get this big ugly thing. And then here we're going to pull out the x terms. So here we only have two different kinds of terms. We have an x e to the negative 2x and an e to the negative 2x. So I've just pulled out all the coefficients from those, split it up like that. You see it's in the same form as over here on the right hand side. So over here we have no x e to the negative 2x terms, so the coefficient should equal 0, and 4a plus 6a plus 2a is 0a, so that's good. That'll just drop away. Negative 4 plus 3, that's negative a e to the negative 2x equals e to the negative 2x. So we know a equals negative 1. Our yp is negative x e to the negative 2x. So now for the final solution, y equals c1 e to the negative 2x plus c2 e to the negative x. That's our homogeneous solution from up here. And we've simply added yp onto it, and the negative x e to the negative 2x. That's it. That's the solution.